Hello, in this lecture we will find the area of the green triangle. In the drawing we have triangle ABC that is an equilateral triangle. That is to say, in this triangle all the sides of this triangle are equal to each other. AB equals to BC equals to AC, and all the angles in this equilateral triangles are equal to 60 degrees. Angle BAC equals to 60 degrees, and also angle ABC equals to 60 degrees, and angle BCA equals to 60 degrees, and AB equals to BC equals to AC. AB equals to BC equals to AC. It is true for any equilateral triangle. All the angles of any equilateral triangle are equal to each other, and all the angles of an equilateral triangle are equal to 60 degrees. Okay, AB equals to BC equals to AC, and we know that AF equals to BF, and BD equals to 2 units, and DC equals to 4 units, and we want to find out the area of the green triangle EFD, this green triangle. Okay, so we know that AB equals to AC equals to BD, but equals to BC, but BC equals to BD plus DC. BC equals to BD plus DC, and we know that BD equals to 2 units and DC equals to 4 units, so BC actually equals to 2 plus 4 units, so BC equals to 6 units, and that is the value of all the sides of this equilateral triangle equal to 6 units. Okay, but we know that AF equals to BF and AB equals to 6 units, so we define AF as X. If AF equals to X and AF also equals to BF, then BF also will be equal to X, and we actually know that AF plus BF equals to AB, so AB equals to 6 units, and AB equals also to AF plus BF, that is to say to AF that is X plus BF that is also X, so AB equals to 2X. Okay, so we have this equality that states that AB equals to 6 and equals also to 2X, so we can derive this equality that 6 equals to 2x, 2x equals to 6 units. We can divide this equality by 2 and we will get that x equals to 3 units. Okay, x equals to 3 units, that is to say BF equals to 3 units and AF also equals to 3 units. Okay, we will define FD, line segment FD, as A, that is to say A equals to FD and we will define DE. Line segment DE will be defined as B, that is to say B equals to DE, okay? And we will find out the value of FD that equals to A by using the law of cosines in triangle BFD. Okay, what is the law of cosines? Okay, the law of cosines. So, what is the law of cosines? Actually, in any triangle, if we have, for example, triangle if this side of the triangle equals to A, this side equals to B, and this side of the red triangle equals to C, then according to the law of cosines, C square, and also we know that the angle between side A and side B is theta. This angle is theta. Then according to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosinus of theta. Okay, so in any triangle, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, in any triangle, C square equals to A square plus B square minus 2 times AB times cosinus theta. Okay, so we actually will implement the law of cosines in the small triangle BFD, in this small triangle BFD. According to the law of cosines, FD square or A square, FD square equals to BF square plus BD square minus 2 times BF times BD. Times cosinus 60 degrees. Okay, so we actually implemented the law of cosines in triangle BFD, the small triangle BFD. According to the law of cosines, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Again, FD square, according to the law of cosines, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, but what is FD? What is FD? FD is defined as A. So FD square is A square equals to BF square. BF equals to 3. So BF square is 3 square. 3 square is 9 plus BD square. BD equals to 2 units. So BD square is 2 square. And 2 square is 4 minus 2 times BF is 3 times BD is 2. So 3 times 2 times cosinus 60 degrees. Cosinus 60 degrees is 1 over 2. So in total we got that A square equals to 9 plus 4 is 13 minus 2 times 3 times 2 over 2. 2 over 2 is 1, so 2 is cancelled. So we have here 13 minus 6, okay? So A square A square equals to 13 minus 6. And 13 minus 6 is 7, so A square equals to 7. Okay, we got that A square equals to 7. Now we'll take a root out of this equality and we will get that A equals to the root of 7 units. A equals to the root of 7 units. So we can write here that A equals to root 7 units. Okay. In the next step, we will define angle BFD as theta. That is to say, angle BFD equals to theta. We will define angle BDF as alpha. That is to say, angle BDF equals to alpha. And we will also define angle EDC as gamma. Angle EDC equals to gamma, and we will define angle DEC as beta. Okay? And we will find the value of sinus theta according to the law of sines. What is the law of sines? The law of sines. Actually, the law of sines applies to any triangle. In any triangle, if we have triangle this side of the right triangle equals to A, this side equals to B, and this side of the right triangle equals to C. This angle equals to alpha. This angle equals to beta. And this angle equals to gamma. Then, according to the law of sines, the following relationship exists between the sides of the right triangle to the angles of the right triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. And it is true in any triangle. This equality is true in any triangle. Again, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. That is the law of sines that is true in any triangle. Okay? Actually, also the law of cosines is true in any triangle. Okay, in any triangle. Okay, so we can implement the law of sines in the small triangle BFD, this small triangle BFD, according to the law of sines. In triangle BFD, BD over sinus theta equals to FD over sinus 60 degrees. Again, BD over sinus theta equals to FD over sinus 60 degrees. Okay? In triangle BFD, in this triangle, BD over sinus theta, BD over sinus theta equals to FD over sinus 60 degrees equals to FD over sinus 60 degrees. Okay, the value of BD is 2 units. It is given us in the question, and sinus theta is sinus theta equals to FD. We have already found that the value of FD equals to A, that equals to the root of 7 units. Okay, so the value of FD is root of 7 units over sinus 60 degrees, and the value of sinus 60 degrees is root 3 over 2. Okay, so we actually got that 2 over sinus theta equals to the root of 7 over root of 3 over 2. Because BD is 2 units, sinus theta is sinus theta, FD equals to root of 7 units, and sinus 60 degrees equals to the root of 3 over 2. Okay? Here we will put 2 in the numerator, here near 7 unit, root of 7, and the root of 3 will be located in the denominator here. Okay, very simple arithmetic. We will get that 2 over sinus theta equals to 2 over root 7 over root 3. Okay? 2 over sinus theta equals to 2 times root 7 over root 3. Okay? So, in the next step, we'll multiply this equality by sinus theta. And we will get that 2 equals to 2 times root 7 over root 3 times sinus theta. Okay? We multiplied this equality by sinus theta, and we got that 2 equals to 2 times root 7 times sinus theta over root 3. Actually, we have 2 in the numerator of this, on this side of the equation, and we have 2 in the numerator of this side of the equation, so we can cancel 2. What is left after we cancel 2? Actually, it is 1 equals to root 7 over root 3 times sinus theta. Okay? Here we multiply the equality by root 3, and we will get that root 3 equals to root 7 times sinus theta. Okay? Root 3 equals to root 7 times sinus theta. Here we divide the equality by root 7 in order to get the value of sinus theta. And we will get that the value of sinus theta equals to root 3 we divide the equality by root 7, we will get that sinus theta equals to root 3 over root 7. Okay, so we found that the value of sinus theta equals to root 3 over root 7. We will also find the value of cosinus theta and we will use the first trigonometric identity in order to find out the value of cosinus theta. Our first trigonometric identity is sinus theta squared plus cosinus theta squared equals to 1. Okay, this is our first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Now we will subtract from this identity sinus theta squared from both sides of the equation, and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay, cosinus theta squared equals to 1 minus sinus theta squared. Actually, we subtracted minus sinus theta squared from this identity, and we got that cosinus theta squared equals to 1 minus sinus theta squared. In the next step, we will take a root out of this equality, and we will get that the value of cosinus theta is actually the root of 1 minus sinus theta squared. Okay, the value of cosinus theta is the root of 1 minus sinus theta squared. But we have already found that sinus theta sinus theta equals to the root of 3 over root 7. Okay? Sinus theta equals to the root of 3 over root 7. Okay? But if sinus theta equals to the root of 3 over root 7, then sinus theta squared will be equal to 3 over 7. Okay, sinus theta squared equals to 3 over 7. If sinus theta equals to the root of 3 over root 7, then sinus theta squared equals to 3 over 7. So we can substitute sinus theta squared in this equality by 3 over 7, because sinus theta squared equals to 3 over 7. Okay? So we will get that the value of cosinus theta equals to the root of 1 minus sinus theta squared, but we know that the value of sinus theta squared equals to 3 over 7. Okay, So we got that the value of cosinus theta is the root of 1 minus 3 over 7. 1 minus 3 over 7 equals to 4 over 7. So in total we got that cosinus theta equals to the root of 4 over 7. Okay, cosinus theta equals to the root of 4 over 7. But the root of 4 is 2, so we can write here that cosinus theta equals to 2 over root of 7. Okay, so we got the value of cosinus theta. Cosinus theta equals to 2 over root 7. And we have already found out the value of sinus theta. We know that sinus theta equals to the root of 3 over root 7. Okay? So we got the values of cosinus theta and sinus theta. Okay? In the next step, we will create 4 equations. The first equation states that the sum of angles in any triangle equals to 180 degrees, and especially in the small triangle BFD, the sum of its angles equals to 180 degrees. Okay, so in triangle BFD, the sum of its angles is 60 degrees. That is our first equation. The sum of the angles in triangle BFD is 60 degrees plus alpha plus theta. And we know that the sum of the angles in any triangle, and especially in triangle BFD, equals to 180 degrees. Okay, so that is our first equation. Our first equation states that the sum of the angles in any triangle, and especially in triangle BFD, equals to 180 degrees. That is to say, 60 degrees plus alpha plus theta, that is the sum of the angles in triangle BFD, equals to 180 degrees. Okay, the same rule is true also about triangle DEC. The sum of the angles in triangle DEC also equals to 180 degrees. Okay? Our second equation states that the sum of the angles in triangle DEC in this triangle equals to 180 degrees. What is the sum of the angles in triangle DEC? It is 60 degrees plus gamma plus beta. And we know that the sum of the angles in any triangle, and especially in this triangle, equals to 180 degrees. Okay, so in this way we actually created the second equation that states that the sum of the angles in triangle DEC equals to 180 degrees. 60 degrees plus gamma plus beta, 60 degrees plus gamma plus beta equals to 180 degrees. This is our second equation. In the next step, we will add equation number 1 to equation number 2. Okay? We will add equation number 1 to equation number 2. And we will get equation number 3. So equation number 3 is the addition of equation number 1 to equation number 2. 60 degrees plus 60 degrees equals to 180 degrees. And in the first equation we have alpha plus theta plus alpha plus theta. In the second equation we have gamma plus beta. And in the other side of the equation we have 180 degrees plus 180 degrees is 360 degrees. Okay, so we added equation number 1 to equation number 2, and in this way we created equation number 3. So from equation number 3 we will subtract 180 degrees. Okay, we will subtract 180 degrees from equation number 3, and we will get that alpha plus theta plus gamma plus beta equals to 600 degrees minus 120 degrees. It equals to 240 degrees. Okay, so that is our third equation that states that alpha plus theta plus gamma plus beta equals to 140 degrees. Okay, then we will create the fourth equation. The fourth equation will be the following statement, that the sum of the angles in the upper side of a straight line or line segment equals to 180 degrees. So if we will focus on point D at side BC, we will look at side BC, and actually the sum of the angles in the upper side of line segment BC equals to 180 degrees. BC is a straight line, and the statement E is that the sum of the angles in the upper side of a straight line equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay? So our fourth equation is that alpha plus 90 degrees plus gamma equals to 180 degrees. That is to say, the sum of the angles in the upper side of a straight line or line segment equals to 180 degrees. So, according to our fourth equation, alpha plus theta plus gamma, that is the sum of the angles on the upper side of line segment BC at point D equals to 180 degrees. Alpha plus 90 degrees plus gamma equals to 180 degrees. Here we can subtract 90 degrees from equation number 4. Okay. And we will get that alpha plus gamma equals to 90 degrees. Okay, we subtracted 90 degrees from equation number 4, and we got that alpha plus gamma equals to 90 degrees because 180 degrees minus 90 degrees is 90 degrees. So we have on the fourth equation alpha plus gamma equals to 90 degrees. Okay, but in the third equation we also have alpha plus gamma. Here we have alpha plus gamma. And from the fourth equation we know that alpha plus gamma equals to 90 degrees. So we can substitute alpha plus gamma on the third equation by 90 degrees because alpha plus gamma equals to 90 degrees. Okay? So we'll substitute alpha plus gamma by 90 degrees on the third equation, and we will get that $90 degrees plus theta plus beta equals to 240 degrees. That is our fourth equation. We subtracted alpha plus gamma by 90 degrees because alpha plus gamma equals to 90 degrees. So here in the third equation we'll subtract 90 degrees from the third equation. Okay. We'll get that theta plus beta equals to 90 degrees to 150 degrees. (240 degrees minus 90 degrees equals to 150 degrees. So we got the third equation that theta plus beta equals to 150 degrees. In the next step we will subtract theta from this third equation, and we will get that beta equals to 150 degrees minus theta. Okay. For the third equation we got that beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Very simple. Okay. So we got that sinus beta equals to sinus 150 degrees minus theta. Okay. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Okay. In order to find out the value of sinus 150 degrees minus theta, we will use the second trigonometric identity for sinus alpha minus beta. According to the second trigonometric identity, the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, so this is actually the second trigonometric identity, that sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta times cosinus alpha. Then we will say that alpha equals to 150 degrees when we will define beta as theta. That is to say, beta equals to theta, and we will find out the value of sinus 150 degrees minus theta according to the second trigonometric identity. So the value of sinus 150 degrees minus theta will be sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Okay, we actually developed the value of sinus 150 degrees minus theta, the value of sinus 150 degrees minus theta according to the second trigonometric identity in the red color, and we got this expression for sinus 150 degrees minus theta. That is actually the value of sinus theta, because sinus theta, the value of sinus beta, because sinus beta equals to sinus 150 degrees minus theta. Okay, what is the value of sinus 150 degrees? The value of sinus 150 degrees is 1 over 2 times cosinus theta, but we have already found out that the value of cosinus theta is 2 over root 7. Okay, minus sinus theta. We have already found out that the value of sinus theta is root 3 over root 7. Times cosinus 150 degrees. Cosinus of 150 degrees equals to minus root 3 over 2. Okay, so we got that 3 times 2 over root 7 minus root 3 over root 7 times minus root 3 over root 2, that is the value of sinus 150 degrees minus theta, that equals to sinus beta. But minus times minus equals to plus, and root 3 times root 3 equals to 3. And we have here 2 in the numerator of this expression, and we have 2 in the denominator of this expression. So we can cancel 2, and we will get that 1 over root 7 minus times minus is plus, plus root 3 times root 3 is 3 over 2 times 1 over root 7. Okay, so we got that 1 over root 7 plus 1 over root 7 times 3 over 2. Here we will take a common factor, we will take out a common factor of 1 over root 7 of this equality, and this is actually the value of sinus beta. Okay, this is the value of sinus beta. Okay, so we will get that sinus beta equals to 1 over root 7. We take a common factor of 1 over root 7, so we take out the common factor of 1 over root 7. So in the brackets we will have 1 plus 3 over 2. Okay. So we got that 1 over root 7 times 1 plus 1, 3 over 2. 1 plus 3 over 2 is 2.5. And 2.5 is actually 5 halves of 5 over 2. Okay? Here, this expression equals to 5 over 2. Okay, so I write it down. The value of sinus beta is 1 over root 7 times 5 over 2. So we actually found the value of sinus beta. Okay, so after we found the value of sinus beta, we will focus on triangle DEC. On triangle DEC, we will implement the law of sines in order to find out the value of B. According to the implementation of the law of sines in triangle DEC, in this triangle, DC over sinus beta equals to DE over sinus 60 degrees. Again, according to the law of sines, the implementation of the law of sines in triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. Okay? According to the law of sines, when we implement the law of sines in triangle DC, we will get that DC over sinus beta equals to DE over sinus 60 degrees. Okay? DC equals to 4 units, and we have already found out the value of sinus beta. The value of sinus beta is 5 over 2 times root 7 and DE equals to B, and sinus 60 degrees equals to root 3 over 2. Okay, so in total we got that 4 over 5 over 2 times root 7 equals to B over root 3 over 2. Okay? We will do this simple arithmetic calculation here. We will get that 4 times 2 over root 7 over 5 equals to 2b over root 3. Okay, we got that 4 times 2 times root 7 over 5 equals to 2b times root 3. Here we have 2 in the numerator on this side of the equation, and we have 2 on the numerator of this side of the equation, so we can cancel 2. And what is left after we cancel 2? 4 times root 7 over 5 equals to b over root 3. So after we cancelled 2, we got that 4 times root 7 over 5 equals to b over root 3. We will multiply this equality by root 3 in order to get the value of b. Okay, we will multiply this equality by root 3 in order to get the value of b. So we will get that the value of b is 4 times root 7 times root 3 over 5 units. So we multiplied this equality by root 3, and we got that b equals to 4 times root 7 times root 3 over 5 units. Okay, so we found out the value of b, and we have already found out the value of a. We know that a equals to root of 7 units. What is the area of the green triangle, the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of the green triangle FDB, the area of triangle FDB equals to B times A. B is the base, A is the height to the base, because A creates 90 degrees with the base. So A is the height to the base. B times A over 2 is the area of the green triangle FBD or FDB. The area of the green triangle FDB equals to A times B over 2. So the area of the green triangle FDB equals to root 7 times root 7 times root 3 times 4 over 5 over 2. Okay. Okay. The area of the green triangle FDB equals to the root of 7 times root of 7 times root 3 times 4 over 5 over 2. 5 over 2 is 2, and root of 7 times root of 7 is 7. So in total you will get that the area of the green triangle FDB equals to 2 times 7 times root 3 over 5 square units. Okay, so we got that the area of the green triangle FDB, the area of this triangle, green triangle, equals to 2 times 7 times root 3 over 5 square units. 2 times 7 is 14, so I will write it down. So the area of the green triangle FDB equals to 14 times root 3 over 5 square units. Again, the area of the green triangle FDB equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle FDB equals to 4.85 square units. Okay, the area of the green triangle FDB equals to 4.85 square units. Okay, the area of the green triangle equals to 1.85 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle FDB, and we have an equilateral triangle. Triangle ABC is an equilateral triangle. That is to say, all its angles equals to 60 degrees, and AB equals to BC equals to AC. And we also know that AF equals to BF, BD equals to 2 units, and DC equals to 4 units. And we want to find out the area of the green triangle FDE. Okay. First of all, we know that BD equals to 2 and DC equals to 6 units. So actually BC equals to BD plus DC again. BC equals to BD plus DC. And we note that BD equals to 2 units and DC equals to 4 units. So BC equals to 2 plus 4 units. That is to say, BC equals to 6 units. And we know that all the sides in an equilateral triangle equal to each other. So AB equals to BC equals to AC equals to 6 units. Okay, AB equals to BC equals to AC equals to 6 units. And also AB equals to 6 units. And we defined AF as X. AF equals to BF. So if AF equals to X, then BF that equals to AF also equals to X. Okay, and AB equals to AF plus BF, that is to say AB equals to AF, that is X, plus BF, that is also X, that is to say AB equals to 2X. Okay, AB that equals to 6 units also equals to 2X. So we have this equality that 2X equals to 6 units. We divide this equality by 2 and we got the value of X. X equals to 3 units. AF that equals to X equals to 3 units, and BF that also equals to X equals to 3 units. Okay, then we defined FD as A, that is to say FD equals to A, and DF as B, that is to say DE equal D. We define DE as B, that is to say DE equals to B. And we found the value of FD, that is A, by implementing the law of cosines in the small triangle BFD. What is the law of cosines? The law of cosines applies to any triangle. According to the law of cosines in any triangle, C square equals to A square plus B square minus 2 times A times B cosinus theta. Okay, again, C square equals to A square plus B square minus 2 times AB cosinus theta. Actually, we implemented the law of cosines in the small triangle FBD. In the small triangle FBD, we can say that according to the law of cosines, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, so according to the law of cosines, FD square equals to BF square plus DB square or BD square, it is the same, minus 2 times BF times BD times cosinus 60 degrees. Okay, actually the only missing variable here is A. We have all the other values in this equality, and the only missing variable is A. So we know that BD equals to 2 units, BF equals to 3 units, and the value of sinus 60 degrees is 1 over 2. So we calculated all the value of this equality, and we found out that A equals to root of 7 units. The value of A, that is also FD, A equals to root of 7 units. Okay, in the next step we define angle BFD as theta, angle BDF as alpha, angle EDC as gamma, and angle DEC as beta. Okay, and we implemented the law of sines in order to find out the value of sinus theta. What is the law of sines? The law of sines apply to any triangle. In any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? So we applied the rule, the law of sines in the small triangle FBD or BFD. According to the law of sines in triangle BFD or FBD, BD over sinus theta equals to FD over sinus 60 degrees. Again, BD over sinus theta equals to FD over sinus 60 degrees. Okay? BD over sinus theta equals to FD over sinus 60 degrees. Okay, and we know that BD equals to 2, sinus theta is sinus theta, FD equals to A, and it's actually A equals to root 7 units, and sinus 60 degrees equals to root 3 over 2. Okay, so the only missing variable here is sinus theta. Okay, we solved this equality and we found out that the value of sinus theta equals to the root of 3 over root 7. Okay? Then, in order to find out the value of cosinus theta, we use the trigonometric identity in order to find out the value of cosinus theta. Our first trigonometric identity states that sinus theta squared plus cosinus theta squared equals to 1. From this trigonometric identity, we subtracted sinus theta squared, and we got that cosinus theta squared equals to 1 minus sinus theta squared. And then we take a root out of this equality, and we got that cosinus theta equals to the root of 1 minus sinus theta squared. But we know that the value of sinus theta equals to the root of 3 over root 7. So the value of sinus theta squared will be equal to 3 over 7. Okay? So we substituted sinus theta squared in this equality by 3 over 7 because sinus theta squared equals to 3 over 7. Okay, and we got that cosinus theta equals to minus 1 minus 3 over 7. 1 minus 3 over 7 equals to 4 over 7. Okay, and the root of 4 is 2, so we got that cosinus theta equals to 2 over root 7, and we also found, we have already found out that the value of sinus theta equals to the root of 3 over root 7. Okay? The next step, we created 4 equations. Equation number 1 states that the sum of the angles in triangle BFD equals to 180 degrees, that is to say 60 degrees plus alpha plus theta equals to 180 degrees. That is our first equation. Our second equation states that the sum of the angles in triangle DEC in this triangle equals to 180 degrees, that is to say 60 degrees plus gamma plus beta equals to 180 degrees. This is our second equation. And then we added together equation number 1 to equation number 2, and we got equation number 3. That is the addition of equation number 1 to equation number 2. Okay? And then we created an equation number 2, equation number 4, that states that the sum of angles in any straight line at certain point, the sum of the angles at certain point in the upper side of any certain straight line or any line segment equals to 180 degrees. If we focus on point D and line segment BC, we can say that the sum of the angles in the upper side of line segment BC equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. And it is also true to say that the sum of the angles in the lower side at a certain point in the lower side of any straight line or line segment equal to 180 degrees. Okay, so our fourth equation states that the sum of the angles at a certain point at an upper side of a straight line or line segment equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. If we focus on point D, the upper side of line segment BC is this. This is the upper side of line segment BC, and the sum of the angles in the upper side of line segment BC at point D is alpha plus 90 degrees plus gamma, and it equals to 180 degrees, and it is true for any straight line. The sum of the angles at the upper side of any straight line at certain point equals to 180 degrees. Okay, so that is our fourth equation, and we got from the fourth equation that alpha plus theta equals to 90 degrees. And we have alpha plus beta in the third equation, so we can substitute alpha plus theta by 90 degrees because alpha plus gamma equals to 90 degrees. We have alpha plus gamma also in the third equation. And we know, according to the fourth equation, that alpha plus gamma equals to 90 degrees. So we can substitute alpha plus gamma by 90 degrees because alpha plus gamma equals to 90 degrees according to the fourth equation. So we substituted alpha plus gamma by 90 degrees in the third equation, and we got that theta plus beta equals to 180 degrees, and beta equals to 150 degrees minus theta. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus of 150 degrees minus theta. Okay, so in order to find out the value of sinus 150 degrees minus theta, we used the second trigonometric identity that states that sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. When we substituted alpha by 150 degrees and beta by theta, and we use this equality in order to find the value of sinus 150 degrees minus theta, and we found that the value of sinus beta is 5 over root 7 times 2. Okay, that is the value of sinus beta. And then we implemented the law of sines in the small triangle DEC in this triangle. According to the law of sines, DE over sinus 60 degrees equals to DC over sinus beta. Again, DC over sinus beta equals to DE over sinus 60 degrees. Okay, according to the law of sines in triangle DEC, the small triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. Okay, and we know that DC equals to 4 units, sinus beta equals to this expression, DE is the missing variable, is B, and sinus 60 degrees equals to the root of 3 over 2. So the only missing variable that we have in this equality is B. Okay, so we put the data inside this equality, and we found out that the value of B is actually 4 times root 7 times root 3 over 5 units. That is the value of B, and we have already found out that the value of A equals to root 7 units. And the area of the green triangle FDE, the area of the green triangle FDE equals to the base of the triangle times the height to the base over 2. So the base is B, the height is A, because the height creates 90 degrees with the base B. This angle is 90 degrees, so FD that equals to A is the height, so A times B over 2 is the area of the green triangle FDE. Okay, so the area of triangle FDE equals to A times B over 2. So we put we substituted A by the value of A and B by the value of B. B equals to A equals to root 7 and B equals to this expression. So we put the values of A and B in the formula for the area of the green triangle, that is A times B over 2. And we found out that the area of the green triangle FDE equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Okay, thank you very much.